tree data structure, right? So in linked list or stacks or queues, if you observe the existing data structures, linked list is in sequence order. It is something in sequence, whether it is single linked list or double linked list, we are storing elements in a sequence. Even in queue also we are storing the elements in sequence. Either this side you are deleting here and you are inserting here. Even in your stack, you are inserting elements are in linear fashion. Means inserting and deleting is happening. They're in order 1, 2, 3, 4. We are following some pattern here. Inserting a new element, deleting a new element, we are following some pattern. Okay, it is happening in order, right? That's why linked list, stacks, and queues are called as sequential data structures. They're called as sequential data structures. Whereas trees, or sometimes they're also called as linear data structures. Why they are called linear? Because they are in a single order, in a straight line, right? After inserting 1, I am inserting 2 or 3. I am following some sequential pattern here. Even in linked list, even if I am inserting at the beginning, I am following some pattern there in insertion, right? That's why linked list, stacks, and queues are called as linear data structures or sequential data structures. Coming to trees, and the next one what we have, graphs. Okay, trees and graphs are your non-linear data structure. They are non-linear data structure, meaning we don't follow any pattern here. For inserting an element, for deleting an element, we don't have any order. I can do it in any way. One more example to understand why they are called non-linear. See, in linear data structure, like the best example of linear data structure is your array.
Sir,
Yes.
sir, do you have any information regarding the result of CA?
Right. So the best example of a linear data structure is your array. How do we insert elements here? You give 1, 2, 3, 4, any way you insert elements. This is a linear data structure. Okay. How are you accessing the elements? You are accessing in order. Either at indexing 0, 1, 2, 3, 4. Either you are accessing 1, 2, 3, 4, 5 or 1, 3, 1, 2, 4 or 1, 3, even number, odd number. You are doing that in sequence. Okay, you are not jumping in random order. If I ask you, give the elements, no, first 1, then 3, then 4, then 2, then 5, then 3. We are not going jumping in any order. We are going in sequence. When you are writing for loop to access the array elements, we are doing in sequence. Or maybe I can jump alternate elements 2, 2, or I can jump 3, 3. This way I can do, but I am not doing it in random fashion. Some pattern I am following. That is linear data structure. Whereas the same array, if it is written as your non-linear, okay, if it is written non-linear, you'll be jumping randomly from here, there, based on some formulas. Okay, so we don't follow any specific pattern in the non-linear data structure. So one such non-linear data structure is your trees. And by this time, with lot of social media or internet things, you might have understood tree structure is something like this. You have a root, you have a child. No, you might have got some idea, you might have studied somewhere. The tree structure looks like this. Let's try to explore. Let us see the important points or terminologies in the trees. What is a tree? Right. Tree is a data structure similar to linked list, but instead of each node pointing simply to the next node, here each node points to number of nodes like this. If I have a linked list, if this is a double linked list, here this is pointing to another node. This is pointing to another node. Again, this is pointing to another node. See, there is no sequence. We are not following any sequence. It is something like this. Okay. So they are pointing to multiple. This is node. This is my head node. Head left is pointing to another node, that is N1. Head right is pointing to N2. Again, N1's right is pointing to N3. Its left is pointing to N4. Right. So we are not following any specific pattern here. Each node points to number of nodes. It is not linking to one. It is linking to multiple nodes. That is your tree data structure. Right. This is an example of non-linear data structure. Okay. So we use tree structure. Tree structure is a way of representing hierarchical nature of the structure. Hierarchical meaning if you have like this. No, in hierarchical you understand the inheritance concept. This is your parent class, these are your child class, again child class are deriving, right? To show such hierarchical properties, we use tree data structure. Okay. In trees, the order of element is not at all important. In stack, we have some order. In queue, we have some order. In stack, what is the order? Last in, first out. In queue, what is the order? First in, first out. Right? But here in trees, we do not have any particular order. It is all random. Right? If you need ordering of information, you have to use linked list, stacks, or queues. Okay. This is an example. See, this is an example of a tree data structure. So it looks something like this. You are filling elements like a tree structure. Okay. You want to know where we need this tree data structure. You want to draw, you're working in a company. That company's the management level you want to display. You want to store information. Who is the superior? Who is the after superior? Who is his descendant? Right, under him, who is the next descendant? That you want to show. Okay, who is the manager? Who are the team leaders? Who are the employees? That kind of nature, if you want to store that information, you want to store, you have to use tree data structure. Here, it is self-explanatory. If you see, A looks like the boss. Under him, there are three, some executive officers are there. Right. Under each of them, there are team members. Right. So this is a tree structure. It looks something like this. That's why it is called non-linear, because there is no particular order. But what is the order here? Is it E first B A, or is it A first C G? Which one I should go? Is it like this? Is it this way, or is it this way? We don't have any pattern. Stacks, you see, you have a pattern. Stacks, you have any order. Queues, you have an order. Linked list, you have some order. Okay, even if it is this. But in trees, we do not have any order. Right? So let's understand terminology. What is root? Root of a tree is the node with no parents. Root is a tree. Root of a tree is the node with no parents. These are called nodes. These are called nodes. Okay, and these are called edges. Nodes and edges. Okay, kind of, you can say branch. This is one branch of a tree. In our normally trees, we have branches, right? Tree has multiple branches. That way you can assume this is one branch, this is another branch, right? So what is your root node? Root of a tree is a node with no parents. So if you see, in this, A is the node which does not have any parent upon. So this is your root. This is the root. And generally the belief is that every tree should have only one node, one root. Every tree should have only one root. That's a standard assumption here. Then can be at most one root in a tree. Next, edge refers to the link from parent to child. So this is called the edge. This is called the edge. If this is the parent, this is the children, then this is the edge. This is called the edge in the tree. Next, a node with no children are called leaf node. Okay, in this graph, a node with no children are the leaf node. It means, see this I. I does not have any other children. That is only the child. After that, there are no children for this I. Then this can be a leaf node. What all can be other leaf nodes? Can you tell? Which all nodes can be considered as leaf node? From this diagram, try to find out the leaf nodes. The nodes E has no children, J has no children, K has no children, right? H has no children, I has no children. All these nodes are the leaf nodes because they don't have any children. Next, children of same parents are called siblings. Children of same parent are called. Normally in our day-to-day life, we say, no, how many siblings you have. So same thing applicable for tree. Always this is the parent, these are the children of this A. So what is siblings here? Now the question is, who are all the siblings of B? Who are the siblings of B? Meaning, for all those whose parent is A, they are the siblings of B. Okay, for all those whose parent is same, they are called the siblings. So in this example, for B, the siblings are C and D. Okay, now can you tell me who are the siblings for K? Who are the siblings for K? K is here. Okay, who are the siblings for K? Just see the graph, the tree structure here, right? For tree, for K there is no sibling because there is no child here. It is empty. So for K there are no siblings, right? Siblings means for all those node whose parent is same, they are called the siblings. Next, node P is called ancestor of Q if there exists a path from root to Q and P appears on the path. Okay, right. Ancestor. Let's see here. In this ancestors. Okay, what is ancestor? Now, for F, you see, for F, who is the ancestor? Meaning F's parent is B, B's parent is A. So the ancestors are B and A. Like your father, then grandfather, then his father. Everybody is our ancestor. Right? We say ancestors. No, same thing here also. In tree also we use the same terminology. We say ancestor means, right, a node P is an ancestor of Q if there exists a path from root to Q and P appears on the path. Okay, so this can be here in this example. We can say this example, you see, G, C, and A can be ancestors of K. For K is the children of G, G is children of C is children of A. So these three are our ancestors for K. Right, the total pipeline of our paternity pipeline. Right. Next, Q is called descendant of P. Descendant means for C. For C, who all are the descendant? Descendant is G and K both. Children, grandchildren. Right? Ancestors, ascendant and descendant, we call it ancestor and descendant. Okay. Continue seeing these different terminologies. Till now it's clear. Now, level of a tree. Right? Very, very important concept, level of a tree. The set of all nodes at a given depth is called level of a tree. Let's see this example. See, right? At this level, root will be always at level 0. Then 1 and 4 are at level 1. 2 and 5 are at level 2. Right? So this is called depth. So here the depth is 0. The depth is 1. This is second, depth is 2. Okay. Root node always, root node is always at level 0. Then level 1 and level 2 and so on. Right? This is an important point, level of a tree. Right? So the root node is at level 0 always. Next, few more terminologies in this trees concept. Depth of a node is the length of the path from the root to the node. Let's see an example. See, what is the depth here? Right. I want to know the depth of F. Depth of F is nothing but the number of edges it has till it reaches root. Right. See the definition again. Is the length of the path from the root to the node. So from this root, I want to find out the depth of F. Okay. From the root, number of edges, the length of the edges. So 1 and 1. So total it is 2. So F, the depth of F is 2. The depth of F is 2. What is your depth of I? What is depth of I? So I node is here, right? The path, the length of the path from root to that particular node. So this is 1, 2. So the depth of I is 2, right? Next, height of the node. Okay, depth of the node, height of the node. Height of the node is the length of the path from that node to the deepest node. Okay, height of the node is nothing but the length of the path from that node to the deepest node, right? So we will see here what is the height of each node. So from let's take example of G. What is height of this G? Right. So from here, see little length of the path from that node to the deepest node. So from G, the deepest node is here only, K only. But if I take C, height of C, if you see, this is the length of the deepest node. So this is height of C is 2. Okay, if you see height of J, this is 1, 2, 3, right? That way you can find out the height of the node. And the important point is height of tree and depth of tree. Okay, don't get confused here. Depth of node we discussed, right? Then height of a tree. What is the height of the entire tree? For each node, there is something called depth or height. For the whole tree, there can be depth and height. Okay, how do we find out that? Right? Height of the tree is the length of the path from the root to the deepest node in the tree. So what is the height of this? Height of this tree, somebody asked you, 1, 2, 3. So height of this tree is 3. Why? From the root, the deepest node is this only. Either this also you can take, this also deepest node, right? That's why height is 3 here. Next, height of the tree is the maximum height among all the nodes. Again, that's also one way. Height of the tree is nothing but the maximum height of among all the nodes. And the depth of the tree is the maximum depth among all the nodes. So if you want to find out depth of a tree, again, that's also same 3. Height and depth are same here. What is level? This is level 0. These 3 are at level 1. These 4 are at level 2. These 2 are at level 3. Right? This is about level. So remember, level 0 we say. Okay. Next. Size of the node is the number of descendants it has including itself. What is the size of the node? Okay. So if we ask you what is size of this node B. So 1, 2, 3, 4. The size of node B is 4. Why it is storing 4? It is holding 4 elements. Along including itself, it is holding 4 elements. What are those 4 elements? B, E, F and I. This is the size of a given node, right? There are so many terminologies. I'll repeat once again. We will go through that. Don't get confused because this is newly you are learning. So this is first time. So 2-3 times if you go through, you will try to understand that. Next, about skew trees. Okay, if every node in a tree has only one child, such trees are called skew trees. Let's see example here. See, every node has only one node, this side or this side or this side. It is not having multiple children. It is having only one child. See the center one here. One is having a left child 2, a right child 3, a left child 4. Right? Such kind of trees are called as skew trees. Skew trees. Okay, it means every node has only one element. Every node has only one element. In that there are two types, left skew tree and right skew tree. If all the children are in the left side, for this node left, again left, again left, this is called left skew tree. And if all the nodes are on the right side, we call it as right skew tree. Right? This is very, very important. I remember in placements there they have asked some question on this left skew tree and right skew tree in some of the Flipkart company. They asked this question. You can check in internet Flipkart previous questions. If you search, you will definitely find a question on these skew trees. Anyhow, once we see the implementation, we will come to know how to solve the problems. Right? So the concept of skew tree is every node has only one children except the leaf node, because leaf node will not have any children. Okay, every node has only one children. Either if every child is on left side, we call it as left skew tree. If every node is on right side, we call it as right skew tree. Right? Yeah. So this is about the basic terminologies in the trees.